All right, so moving along with our basic figures, our sort of basic foundation of geometry, we're going to get into angles today. And so we're going to talk about measuring and classifying angles. A lot of this stuff you've heard before, maybe a couple of things that we're going to add in here that may be kind of new for you. But we talked about naming and measuring line segments before. We'll do that same thing with angles now, and as well as classifying them. Okay, so a lot of definition here for you. You need to write this down. If you want to, take a second, stop the video so you can copy all this in, and then start it back up, and I'll explain what all this stuff means. Okay, so an angle is defined as two rays that share a common endpoint. Okay, now this last part I'm not going to worry about. Okay, because rays, it can be two rays that lie on the same line. As a matter of fact, opposite rays lie on the same line, and they create an angle. Okay, so anyway, an angle is two rays that share a common endpoint. Period. Now they cannot go the same direction, otherwise it's going to be the same ray, right? That's where that second part of the definition is getting at there. Okay, so this is an angle right here. Okay. Two rays, and they're sharing an endpoint here at A, but this is a ray AB, and this is a ray AC. Okay? The common endpoint of the rays is called the vertex. As a matter of fact, from now on, anytime you see the word vertex, you're looking for a corner in geometry, but that's the vertex, there, A. Okay? The two rays are called sides, so these are the sides, so this is the vertex. And these are the sides. Okay. So if I wanted to name the vertex of this angle, I would name it A. If I wanted to name the sides, you're going to have to remember that sides are always rays. So I'm going to name the sides as rays. So ray AB and ray AC are the sides with the ray symbol. Now what you're going to see eventually is that these arrows are going to go away. We're going to stop drawing these arrows, and that's just so that the pictures don't get too overly complicated to look at. Okay. Even though we dropped the arrows, these sides are still rays, and you need to name them as rays. Okay. Speaking of naming things, if I wanted to name the angle, okay, then we have some options. Okay, the best way to name an angle is to use three letters, where one is the vertex, so we're going to use the vertex here, and then we need a point on one of the sides and a point on the other. So we need a point on each side and then the vertex. And when we name it, we're going to use these 3 points as long as the vertex is always in the middle. So angle BAC is how we would name this angle. The idea is that I should be able to, when you name the angle, I should be able to put my pencil on the first point, trace it through the second point, and get to the third, and I should be tracing that angle. That's why the vertex of the angle has to be in the middle. Now, there's nothing wrong with turning this around and making this angle CAB. Because if I start at C, trace to A and over B, I'm still tracing the angle. What I can't do is call this angle ABC, because it's a completely different angle. I'm going to be talking about some angle up here I can't even see. Okay? Now, in a case where the angle is all by itself, then it's proper to use just the vertex and call this angle A. But it has to be all by itself. Now, what do I mean by all by itself? Well, if I were to draw another ray here, and don't draw this into your notes, but if I were to draw another ray here, like this, okay, now there are actually 3 angles here. There's angle DAB, BAC, and DAC. So now if I just try to say angle A, then I won't know which of those 3 that we're talking about. Okay? So here the angle is not all by itself. So we're going to have to use the 3 points to help name whatever angle it is that you want me to look at. Okay? But that's if the angle is not all by itself. If it is all by itself, then you can use angle A. I'm going to add one more way in here. And that is sometimes we'll put a number inside the vertex here, inside the angle, and then we can call this angle 1. So this is angle 1. Okay? We could put a 2 in here, or a 3, or a 4, right? And call this angle 4. It doesn't really matter what number we use, but we can use a number inside the vertex. So that's naming. A couple of more identifiers here, a couple more definition terms for you that's not in here, but interior. If I told you to look at the interior or to find a point on the interior of an angle, and we're talking about here. Okay? Then that means that a point in the exterior would be out here. This is your exterior. Okay? So I think it makes enough sense, but I wanted to sort of point that out so we can identify that when it's time. Okay? All right. Quick practice. Name the angles in this diagram, the 3 angles. And yes, there are 3 angles. So go ahead and give it a shot. Stop the video, start it back up, and see if you managed to name them correctly. Okay? So, did you come up with angle? WXY. That's this guy. Then did you come up with YXZ? Because that's this guy. And then did you locate angle WXZ? Because that's this guy. Okay, those are your 3 angles. Okay, it's not appropriate to just say angle X because I don't know which of those 3 you're talking about. So you don't want to do that. Okay, so there we go, naming. All right, more definitions. So, degrees is the unit of measurement we will use to measure an angle. Okay, a protractor is what that thing is called that we use to measure an angle. And so how a protractor works, okay, when we have an angle, and this is the angle that we're trying to measure here, then, so a protractor has a straight side here, and then has this, what looks like a half circle, right? Well, you want to put, and usually right in the middle of the flat side, there's like an arrow or a tick mark or a line. You want to put the vertex of the angle right at that arrow or that tick mark or that line in the middle, and then arrange the protractor so that the straight edge of the protractor is lined up with one of the sides of the angle. Then the other side can go wherever it needs to go. But one side has to be on the straight edge, the vertex has to be at that middle point in the protractor, and then we're going to look at where the other side goes through. So the other side is there, and it is sitting right at this line, and we've got 2 different sets of numbers that we're going to have to use. Okay, now for this angle that I'm measuring from here to here, that angle measure is bigger than 90 degrees. I think we can recognize that. So we need to use the set of numbers that will give me a measure bigger than 90. And that's going to be these bottom guys down here. That's why the measure of angle ABC is 105. And that's how we would write the measure of angle ABC. Just the lowercase script m in front. The measure of angle ABC is equal to 105 degrees. Okay, and depending on what type of angle we have, that will also help us figure out which set of numbers that we need to use. And what I mean by what type of angle is how we classify it. And these I'm sure you've seen before. An angle whose measure is less than 90 degrees is called an acute angle. An angle whose measure is equal to 90 is called a right angle. An angle whose measure is bigger than 90, that's what that should say there, angle greater than 90, is an obtuse angle. And then this guy down here, this is what I mean by two rays that are lying on the same line. These two opposite rays are lying on the same line, so they can lie on the same line. They're just going to need to be going in opposite directions or be opposite rays, but that creates a straight angle, which is the measure is 80 degrees, sorry, 180 degrees. Okay, that's how you want to write it. So, acute. So we go up here, and if we wanted to measure this angle, we would know that that's an acute angle because it looks like it's less than 90 degrees. There are very few things we get to assume in pictures, okay? But we can pretty much tell that's going to be less than 90 degrees. And so I need to use the set of numbers that will give me a measure that's less than 90. So the top numbers will do that. So this angle in here is 75 degrees. Okay? All right. Now, you should have a protractor given to you in class. If not, if you can find a protractor to practice, that would be good. You use that protractor to practice measuring these angles. Hopefully you have that in your hand now. If you didn't get one from me, if you can find one and practice, that would be good. So I would encourage you to stop the video now, measure these angles, and then we'll talk about what you should come up with. Okay, so again, these angles are here. We wanted to line the protractor up to where the arrow or the middle line of the straight edge is at the vertex of all these angles, and that's at H. Okay, so we look. Angle KHJ is this angle right here. And that is definitely an acute angle. So I'm going to use the set of numbers that will give me a measure less than 90. That's the bottom numbers. And we're right in between there, so this guy is going to be 55 degrees. GHK. GHK comes in through here like this. That's definitely an obtuse angle. It's bigger than 90 degrees. So we want to measure it using the bigger set of numbers, the top set of numbers here. This is going to be 125 degrees. GHJ. GHJ is this angle right here, which is a straight angle. It's flat. And it's going to measure 180 degrees. And then GHL is this angle right here, which there's no ambiguity. There's only one set of numbers that, or actually using either set of numbers will get you to 90 degrees. And that's so obviously a right angle. Okay? So it's measuring and classifying there. So if we were to classify them, I said them as we went through. This would be an acute angle. This would be obtuse. This would be straight, and then this would be a right angle. Okay? All right. Now, angle addition postulate. If we have two adjacent angles, okay, now the words here for the angle addition postulate, and this is going to work a lot like the segment addition postulate. If we have a point on the interior of an angle, so right now we're looking at this as angle RST, and P is a point on the interior, anywhere on the interior, it doesn't matter where, so inside the angle. We can draw a ray through that point so that it creates what we call two adjacent angles. Now we can look at this picture as two separate angles. This guy right here, angle RSP. This guy right here, angle TSP. They're adjacent because they're sharing this side. Ray SP, they're sharing both using ray SP to make them. So these are adjacent angles, what we call adjacent, adjacent angles. Adjacent means next to, means side by side, okay? If we have adjacent angles, then what ends up being true is that if I add angle RSP to angle TSP, then hopefully it makes sense. That's going to give you a measure that's equal to this whole big angle RST. And so we see that down here. The measure of angle RST is equal to the measure of angle RSP plus the measure of angle PST. Okay? And just like the segment addition postulate, it's going to be really helpful if you can write out the postulate in terms of the names of the angles first, and then fill in what you know. For example, this guy right here. We know that the measure of angle LKN is 145 degrees, and we want to find the other two angles in the picture, the measure of angle LKM and the measure of angle MKN. Well, we see that we have a couple of adjacent angles. Angle LKM and angle NKM are both using ray KM. They're sharing a side. So that tells me that the measure of angle LKM plus the measure of angle MKN has to be equal to the measure of angle LKN. Okay? Now we just fill in what we know. Fill in what we know for each angle. Angle LKM is 2x plus 10. MKN is 4x minus 3. So we're going to add those two together. LKN is 145 degrees. There's your equation that you're going to want to go solve for. So you get 6x plus 7 equals 145. Subtract 7. Divide by 6. And we're there. Okay? Hopefully that makes as much sense as the segment addition postulate does. Okay? All right. All right, some more definitions for you. Segments are congruent. Guess what? So are angles. If two angles have the same measure, then they're going to be congruent. Okay? If they're congruent, we'll show it in a diagram by using these guys, these arcs. And even more than that, very often they're arcs with a tick mark in them. And that'll tell you that those two angles are congruent. They're the same. If they are, then we talk about their measures being equal. It's the same thing as the segments. We made a big deal about the numerical measures being equal and the figures themselves being congruent. So the measure of angle A would be equal to the measure of angle B, those numerical measurements. And that tells us that angle A is congruent to angle B. Okay? Now, we had midpoints and segment bisectors that cut segments in half. There are also things called angle bisectors that cut angles in half. An angle bisector is a ray. So again, even though we may cut the arrows off at the end, it's still a ray that divides an angle into two angles that are congruent. Right? So in other words, if I were to bisect angle B right here, it would have to be a ray that would come through and make these two angles congruent, which we put additional arcs in there sometimes. If we're going to use tick marks, then we'll put additional tick marks in it to show that those two angles are congruent. So it cuts the angle in half, basically. All right? So, question here. The photograph shows some of the angles formed by the ropes in a trapeze apparatus. Identify the congruent angles. And the measure of angle DEG is 157 degrees. What is the measure of angle GKL? Okay. Again, I told you we want to be careful about what we assume out of a picture, and we only need to go by what we know. Okay? And what we know in a picture is that the angles with the same number of arcs in them are going to be congruent. So for example, in this picture, angle DEF is going to be congruent to angle JKL because they have the arcs in them. The other thing we know is that angle DEG is congruent to angle LKG because they have the double arcs in them. Okay? Now, excuse me. If the measure of angle DEG is 157 degrees, then we want to know what the measure of angle GKL is. Well, GKL and LKG are the same angle, just named two different ways. But they're congruent, they're equal, so the measure of angle GKL has to also be 157 degrees. That's what it means to be congruent. Okay? So we want to use that idea as well. Kind of like this. In the diagram at the right, ray YW bisects angle XYZ, and the measure of angle XYW is equal to 18 degrees. Find the measure of angle XYZ. When you see from the picture there, if ray YW, that's how we would write it because it is a ray, bisects angle XYZ, then it creates those two congruent angles, angle XYW. So the measure of angle XYW is equal to the measure of angle WYZ. Now what we would also know from this picture, not because of the angle bisector, but just because of the angle addition postulate, that the measure of angle XYW plus the measure of angle WYZ would have to equal the measure of angle XYZ. And we might be able to use that to set up an equation to solve if we need to. But bottom line is this: if XYW is 18, then so is WYZ. And if we want XYZ, this whole big guy here, we're just going to add those two together and get 36. And that's going to be the measure of angle XYZ. Okay? Those are all the examples, all the notes we have. So hopefully that all made enough sense. You have homework out in Canvas that you can download in Notability and start working on it. Okay? And we'll see you next time.